Alright, in this video we're going to be looking at using inverse trig functions. Here we have a triangle. We see that sine theta equals 3 over 5. What we've done before is whenever we have one of the trig functions is we have an answer of one of the side ratios, right? Sine is opposite over hypotenuse, for example. That gives us 3/5. But if we wanted to solve for this angle, what we do is we take the inverse of both sides and we end up getting theta equals sine inverse of 3/5. And this is what I want to point out to you. Whenever you take the inverse of something, your resultant is an angle. So whenever you're taking a trig function, you get side ratios. Whenever you take an inverse function, you end up with an angle. So if I wanted to evaluate sine inverse of 1/2, we'll go ahead and draw our triangle like we did in the last video. And here I have my angle of 30 degrees or pi over 6. This sine inverse, because it's an inverse function, my answer is going to be this angle. And let's go ahead and write that in radians. This would be pi over 6. I've gone ahead and drawn my triangle for cosine inverse of negative root 2 over 2 or cosine inverse of negative 1 over root 2. We find ourselves in the second quadrant with an angle of 45 degrees. But this is only our reference angle. The angle that's going to be our answer is this big angle all the way from 0 degrees. So, since this is a pi over 4 degree angle, and we know this x-axis is at pi, all I need to do is do pi minus pi over 4, which is going to give me 3 pi over 4. This would be my answer if I was evaluating the cosine inverse of negative root 2 over 2. Here we've got arctangent negative root 3. I changed this to arctangent of negative root 3 over 1. I found my triangle, which is going to be in my fourth quadrant because I've got a negative y value here. And my range for arctangent is from negative pi over 2 to pi over 2. I find that my reference angle is going to be 60 degrees, which would also be pi over 3 if we wanted it in radians. Now, instead of doing 2 pi minus pi over 3 to get this huge angle right here, we have to keep in mind that the range of pi is from negative pi over 2 to pi over 2. That's this distance in here. So, with that in mind, instead of doing that 2 pi minus pi over 3, I can just write my answer as negative pi over 3. All of our answers have to lie within the range of each inverse function. Looking at cosine inverse of 0, I could change that to 0 over 1, which would give me a point here. This is one of the examples that lands exactly on the axis. In this case, the positive y-axis, as we'd get an x over r, or 0 over 1. Remember, the cosine inverse is looking for the angle, which in this case is going to be pi over 2. Let's try something a little different. Here we want to find the sine of the sine inverse of 3/5. Remembering that this sine inverse is an angle, so we want sine of this angle. Let's start inside the parentheses and work our way out. Based on this sine inverse of 3/5, I'm going to get at my triangle right here in quadrant 1. I can use Pythagorean theorem to find out that this side, my adjacent side, is going to be 4. Now that I have my triangle here, all I need to do is find the sine of this triangle based on whatever this theta is. We don't need to find this theta because we've already got our triangle drawn. So if I find the sine of this triangle, I'm going to get opposite over hypotenuse or 3/5, which you might note the sine and sine inverse, or any trig function and its inverse, are always going to cancel themselves out, leaving you with just whatever you started with. Here we've got tangent of the cosine inverse of negative root 2 over 2. Again, let's start with this inside the parentheses. Making our triangle based on this, we get a triangle in quadrant 2 that is a 1, 1, square root of 2, or 45, 45, 90 triangle. After drawing our triangle here, it's not really important what the theta is because we want the tangent of this angle. We already have our triangle drawn, so we can just use tangent, the opposite over the adjacent. That's going to be 1 over negative 1, or simply negative 1. This time we have sine inverse of cosine 2 pi over 3. This is a little different because the inverse is on the outside, and on the inside we just have a normal trig function. So if we wanted to find our trig function, first we want to draw the triangle based on cosine 2 pi over 3. 2 pi over 3 we could find out is going to end up in this quadrant with a reference angle of pi over 3 or 60 degrees. Based on this 30, 60, 90 triangle, we're going to get side lengths of root 3 here, 1 here, and 2 here. Now, because we found the cosine of 2 pi over 3, that means we want the adjacent over the hypotenuse. So I'm going to go ahead and replace this cosine 2 pi over 3 with 1/2, making us want to find the sine inverse of 1/2. After drawing that triangle out, I have my opposite over hypotenuse, 1 over 2. I end up with my triangle in quadrant 1 and another 30, 60, 90 triangle. This time, theta is going to be 30 degrees or pi over 6. And that's going to be your answer because this is the angle we're looking for since we have the sine inverse. If you ever see something a little more complex, for example, sine of tangent inverse of 1 minus sine inverse of 1, don't get too thrown off. Just take it a piece at a time. So starting inside the parentheses, I would find tangent inverse of 1. If you do that, you'll get pi over 4. Next, go ahead and find sine inverse of 1. If you do that, you should get pi over 2. Then if I just sub these values in, I'm just going to go ahead and get my sine of pi over 4 minus pi over 2. Again, all I did was sub in these values for my inverse functions that I found here. Going based on that, that's going to leave me sine of pi over 4 minus pi over 2 would be negative pi over 4. From there, we can draw our triangle at negative pi over 4 degrees. It's going to be in here, and a 45, 45, 90, 1 root 2. And if I want sine, I'm looking for my opposite over hypotenuse, or negative 1 over square root of 2. And of course, we can rationalize that to negative root 2 over 2. So, again, don't get frazzled. Just take each individual piece first, do what's inside the parentheses, and go from there.